goes on and on and on. Today, the focus is going to be on probability distribution that we call binomial distribution in the outline. I'm actually going to introduce it to binomial distribution, the statistical properties of binomial distribution, when do we use it. Then I'm also going to walk you through how to demonstrate, where I going to present you some code, how we run that in R. Okay, now I want to go into binomial distribution right now. I need you to pay attention. We find ourselves in a world where different things happens, and when you try to perform experiment, we got different outcome. Okay, now situation where we got two possible outcomes. I'm going to say that again. Situation where you got two possible outcome. Okay, the idea of binomial distribution is actually going to work. I perform experiment, and there are two possibilities. Okay, two possibility. The appropriate probability distribution will be binomial. Okay, so maybe I got a coin. I toss a coin. There are two possible outcomes, either head or tail. Or I'm a businessman. Okay, if I go into business, there are two possibilities, whether I'm making profit or making loss. Okay, writing exam, either you passing exam or failing exam, or whether somebody have insurance or not, or whether for instance, you have an offer for a credit card and you read the terms and you realize that's not favorable at all. You could reject of an offer. You can also accept an offer. So situation where you actually want to answer probability question, okay, where there are two possible outcomes, you're actually going to use binomial distribution. So generally speaking, I'm actually going to say there are the two possible outcomes can be generally classified as success and failure. Does that make sense? Okay. And you know what? Binomial distribution is actually it belongs to a discrete type probability distribution. The other time, I walk you through normal, I walk you through uniform distribution, and normal distribution. They are classified under continuous type distribution. But binomial distribution that we want to talk about is a distribution of discrete, random variable. Does that make sense? Okay. Now, you're actually going to see us using an uppercase. Take a look at this guy now. Okay. Maybe you are interested in tossing a coin. Okay. A good number of times. Okay. And in each toss, there are two possibilities. Okay. In each toss, there are two possibilities. So binomial experiment, when you are flipping a coin, you are performing binomial experiments. What makes it binomial experiment? Because there are two possibilities. So that you see head or you see tail. So there now, total number of head out of five coin tosses. Maybe you toss a coin 5 times and you are interested in the numbers of head that shows up. Okay. Now the numbers of head that is going to show up, it could be 0, it could be 1, it could be 2, it could be 3, it could be 4, and it could be 5 because you toss it 5 times. Does that make sense to everyone? Okay. The total number of subjects out of 50, okay, that die during a clinical trial. Now, I'm actually going to start the application of binomial in medical field. Before I'm actually going to go into properties of binomial right now, I need you to follow first, like, what is the application of binomial? So I'm going to start from medical field. I'll go to manufacturing. I'll go to economy. Okay. And I'm going to go to environmental science. And I need you to listen. Okay. Now, we don't just do maths. There's a reason why we do what we do. If you understand our intention, you'll be able to understand the mathematics aspects. Don't rush into mathematics aspects. So four of us understand the underlying, the background information around that. And that's what I want to give you right now. Okay. Let me tell you this. Unfortunately, it is not 100% of patients that will benefit from any medical intervention. And let me tell you this. Do you know what is going to bring binomial in? Is because a patient can survive or a patient can die. Those are two possibilities. And that's why binomial is coming in. So in a medical field, you actually have 50. I want to believe success, the number of success for doctor is to be able to rescue the whole 50. Okay. So X now would be the, X could be the number of patients that survive or the number of patients that die. So you are going to be the one that will choose your characteristics of interest. Does that make sense? I'm going to give you another example in medical field. Pfizer claimed to have, developed a vaccine for COVID, and they claimed that the vaccine has 95% efficacy. They did not claim 100%. It's not going to happen in a stochastic world. It's never going to happen. Our model, whatever intervention we have, can never give us an exact characterization of reality. There's always going to be an error. Now, if they have claimed that 95% of the people that get vaccinated with their vaccine, we prevent COVID, then what we can do, if we randomly go into the population that have been vaccinated and we choose a sample size of 20, we can figure out the probability of 5 getting COVID or of 10 getting COVID. Okay, so with the binomial idea, we can do that. Okay, I'm going to leave medical field right now because before we go into property of binomial, I will explain the implication in manufacturing. Every manufacturing where the industry where they manufacture products, they actually have a target value in mind. At times they could come with some product that did not conform to specification. They record defects. Has anybody heard about defects? Defects, okay. Now they want to minimize defects, but no matter what they do, there's always going to be defect. Binomial distribution also, we can use binomial distribution to figure out the probability that if a quality control officer should randomly select products, okay, what is the probability that if they select 20, 5 will be defective? Okay, binomial idea can be used in that. Okay, because in the manufacturing industry, it's either they have, when they produce a product, it's either it is good or bad. Does that make sense? I'm going to leave manufacturing industry. I'm actually going to go into environmental science. Now, in environmental science, we'll talk about pollution. Okay, and we have an agency that regulates whatever pollution is going to be going into the atmosphere. Let me focus on water pollution now. If I actually, let's say it is assumed that 5%, or maybe the threshold is, it shouldn't be more than 5% if there's going to be maybe pollutant at all. Okay, we know there's going to be pollutant, but we don't want, we set a threshold. Maybe we know that the probability that a particular water sample will exceed the threshold is 5%. Now, if I now go into a river and I generate a lot of water sample, what is the maybe 20 samples? What is the probability that 5 or more water sample will be contaminated? I can use binomial to answer the question. Okay. And lastly, okay, for binomial, we can use it in ecology, where you want to know if I visit forest, okay, you are looking for endangered species, okay? What is the probability out of 20 forest areas that I enter? Okay, maybe 5 as the endangered species. It's either endangered species exists in a particular forest or not. That is binomial. I think I've given you enough example on I forgot this. Economy. You know, you are selling products and you have a website. Customer will visit your website. When customer visit your website, it's either they purchase or not. That's a binomial. So if you let's say for instance, you look at the rate at which customer visit your website, and because of that, maybe you are able to know that 10% of them, it's only 10% of the customer that visit your website that purchase your product. Now the question now, if I randomly select 20 customer that visit your website, what is the probability that 5 or more, or 6 or more, or 7 or more will purchase your products? If you want to answer that question, you're going to go binomial. Okay, now you understand the basis, you understand the significance of binomial distribution right now. I will now go into mathematical property. Now, let me tell you this. This is the reason why I'm going to tell you why I understand my statistics perfectly, why I understand my mathematics perfectly. I don't go straight into mathematical equation. No, I'm not going to go there. What I will do first is, what is the meaning? What is the connection to reality? Before I'm going to go there, your mathematics is going to make sense to you if you really understand the reason why you're doing the math. Does that make sense? Now we want to go into the properties of binomial. Now we know the significance of binomial, but we want to look at the properties. Number one, we must have fixed numbers of trials. In advance, if I want to collect sample, I need to know ahead of time how many samples do I want to collect. The numbers of trial is fixed. It's not subject to variation. Number two, the samples have to be independent. Okay, if I take, let's say I'm talking about water sample now for pollution, okay, now if I investigate this water sample and I want to investigate another one, the result that I have in that one should not affect a different one, which means the sampling procedure that we use in binomial is sampling with replacement. Does that make sense? Binomial require you sampling with replacement. It is only when you sample with replacement that you're actually going to have independent trials. Does that make sense? Now, number three, each trial will have two possible outcomes. Each trial. When I take a coin, could be head or tail. When I take a sample, a water sample, or investigating that for quality, it could be contaminated or not. Does that make sense? That's exactly it. You can see the way we're doing it now. We're linking that to real life. We're not just saying each trial has two possible outcomes, success, failure. Doesn't make sense when you're doing it that way. Link that, relate that to real life. And that will better your understanding. And you know what? Another property now, since we have classified the two possible outcomes into success and failure, success is going to be an event, failure is also going to be an event, then each of them will have their own probability. There will be probability for success. There will be probability for failure. When somebody passes an exam, and the person scored less than 100%, then the probability of passing is more than failing. Does that make sense? If somebody failed an exam, the probability of failure is more than passing. Does that make sense? Okay, for the two possible outcomes, there exists probability for them. What do I mean by that? It means there exists weight for each of them, the frequency for each of them. That's exactly what we mean. Therefore, the success has a probability of P. If success has a probability of P, and failure also exists, what would be the probability of failure? That would be 1 minus P, because we're using the law of complements. Does that make sense? Because the probability of success and the probability of failure, when I add them together, it should give me 1. Why? Because success and failures are mutually exclusive. So when two events are mutually exclusive, of course, the probability of success plus probability of failure is going to be 1. Now, I want to move right now. Do you remember the other time when I was walking you through normal distribution? We normally write this. Do you see that? For normal, we normally write x. That means x followed normal with the mean and standard deviation. But how do we write binomial mathematically? We write binomial mathematically as this. That means x followed binom, by in. That's an abbreviation for binomial. And there are 2 parameters in binomial that you need to be able to know before you can move forward. N and P. N is the numbers of trials. P is the probability of success. Does that make sense? Okay. Now that is how we specify binomial. And let me tell you this. That very x in binomial is discrete. X in normal is continuous. I needed to pay attention to that. Because of that, we got 2 parameters for binomial distribution. They are N and P. We got 2 parameters for normal. It's mu and sigma. I just wanted to take notes of that. Okay, I want to go into an example right now, and I needed to pay attention. I needed to take a look at this. Take a look at this now. In the following experiment, okay, in the following experiment, does random variable x follow a binomial distribution? If yes, identify N and P. If not, explain why. Let me tell you this. This is the strategy. If you want to know whether a particular random variable follow binomial distribution, you should be able to identify 2 things. 1, numbers of trials. 2, probability of success. But let me tell you this. At times, probability of success may be unknown. That's no problem. But the numbers of trials have to be known. It has to be fixed. Does that make sense? And let me also tell you another way to discover whether to identify binomial. It should be sampling with replacement and not sample without replacement. Now, I needed to take a look at this now. You are given this scenario. Toss a coin 3 times and let x be equal to numbers of heads. That is it. That was the question. And they wanted to decide either this is binomial or not. And I'm going to say yes. This is binomial. How do I know? Because the numbers of time the coin is tossed is given 3. Can you see now? It's given. And not only that, I also know the probability of success because that's a natural one. That's a theoretical one. If I have a coin, of course, everybody know we got to size in a coin, right? At every point in the experiment, it's always going to be half, 1/2. So that I see head or I see tail. When I take a coin right now, I toss it once. There are 2 possibilities. The probability is 1/2. I toss it again, it's still 1/2. When I continue to go from trial to trial, the probability of success remains the same. Does that make sense? Okay, that's binomial. Now, we want to go into another one now. We want to investigate whether it's binomial. We pull 100 people, okay, and let X denote the number that supports Iraq war. Is either an individual support war or not. That's binomial. Right now, they pull 100 people. We know the numbers of people, the numbers of trial. Okay, even though we don't know the probability right now, that's okay. That is still binomial. Does that make sense? Okay. Now, I want to go into number 3 right now. I need you to take a look at number 3 now. Okay. I said, toss a coin until you get 10x. Oh my God. Toss a coin until you get 10x. It could take forever. In that situation, you don't know the numbers of trials ahead, and that can never be binomial. Does that make sense? It's another distribution in statistics that you will not is beyond the scope of this course, that we call geometric distribution. So if you take higher level course in statistics, you're going to come across that. Okay, so when you choose it, because the end is not fixed, and that's why binomial is not going to work. That's why the negative binomial or geometric distribution is going to work, but that is beyond the scope of this course. Okay, number 4. I need you to take a look at this right now. Why am I showing you all of this? Because we got some phenomena that also have 2 possible outcomes, but not binomial. It is not all of that binomial can be model. We know what we look out for. Now take a look at this. Suppose an uncontained 3 red marbles and 2 blue marbles. How many possible outcomes? 2 in terms of color. Red marbles, blue marbles. Those are 2 possible outcomes. And we may be suspecting whether we can use binomial to answer probability question. But let's see. Choose 2 marbles without replacement. Because they mention without replacement, even though we have 2 possibility in terms of what the response is, we cannot use binomial. We can only use binomial for with replacement. Because without replacement, we actually violate independent assumption that we talked about the other time. Does that make sense? And what is the appropriate distribution for use? It's hypergeometric. There's so many distribution in statistics. You don't need to care about hypergeometric because it's beyond the scope of this course. We're only trying to tell you information that even though we got 2 possible outcomes, but because of the mode of sampling, here we're actually doing that without replacement. Binomial is not going to work. Okay, consider now. Now, we now want to walk you through function. If I'm working with binomial, what is the probability function? If I want to answer a question that has to do, where the process is binomial, how do I answer probability question? And for us to be able to answer a probability question, we need a formula. What is the formula for binomial? And that's exactly what you see in here. That guy is trying to say the probability of an uppercase S equal to S. X is the number of your characteristics of interest, which could be number of sources. It could be number of defects in manufacturing, okay, process. It could be number of contaminated, water samples. Okay, it could be number of whatever. And N is the numbers of trials. X is the number of sources. Now, if I try N time, and how many sources do I have? That's why you see combinatorial analysis and combination X. And don't forget, the number of sources is X. The probability of success is P. Oh my God. Because the probability of success is P, that is why P is raised to power S. Because S is the number of sources. P is the probability of success. Now, what is the probability of failure? I told you the other time, the probability of failure is going to be 1 minus P. What is the number of failures? If I try N times and the number of success is X, Can somebody tell me for extra credit, what is the number of failure? If I try n times, n time, and x is the number of success, what is the number of failure? Okay. N minus S, send me a message for extra credit. Is that what you want to say? Be honest. Or want to say N minus S too, right? Send me a message for extra credit. Okay. That is why you see 1 minus P as a power N minus S. 1 minus P is the probability of failure, and the power is the number of failure. But you know what? Don't be scared. Using this formula, because we got a way out, we can make use of out. Okay? And I needed to pay attention. So what I'm trying to do here is, if I want to solve this one, for instance, I have 5 combination 2. Okay? This is just giving you an idea of what we're going to get, when you do that. But like I said, we're actually going to do that now. But I want to move it to another example. Suppose that the multiple choice portion of an exam contains 3 questions. Please pay attention. 3 questions, each with 4 possible choices. That's a multiple choice, right? An unprepared student decides to guess the answers at random. Okay? Let X equal to the number of questions the student guessed correctly. This is going to be binomial. Why? Because it's either student guess answer correctly or not. There are 2 possible outcomes. And not only that, we got the numbers of trials here. The numbers of trials is the number of questions. 3 questions. Okay? Now, when you take a look at 4 options, one of the options is correct. The probability of the correct answer is 1/4. Does that make sense? If I want to write the distribution now for S, it's going to be that. Is there anyone who doesn't understand how we actually write the distribution of S to be that based on that question? Because we got 3 questions. That implies 3 numbers of trial is 3. And it's only one, and we got 4 options to choose from. One of the options is correct. Then the probability of a correct answer will be 1/4. Okay. Then automatically the probability of incorrect answer will be 3/4. Does that make sense? Okay. Now that is how that one is settled. I need you to take a look at this guy now. Let C be the event of a correct answer, and let W, okay, be the event of a wrong answer. Write down the sample space for this experiment. I'm going to show you how to do that. Give me 1 second. Okay. Maybe I should use, I'm going to use this side. Okay, let me see. Let me see one side. Okay, so maybe I'm going to use that side. I need to focus on the board now. Does that make sense? Okay. Oh, don't go. Gotta come down. Okay, that guy is coming down now. Okay, we got this. Go ahead. Okay. It's not compulsory that you have it in this order, but uh, going by the tree diagram, it will be easy to figure out. But provided you're gonna have it's gonna be eight, the number, okay? And do you know I can even know the totality of possibility. How many sides do we have in a coin? Two, right? And I'm tossing it three times. What is 2 raised to power 3? 2 raised to power 3, that would be 8. And that's why we got 8. Go ahead. It doesn't matter. It doesn't matter in the sample space. Okay? Now, if I have this now, I need you to pay attention now. If I have this guy now, I need to assign a random variable. What is a random variable? The numbers of the answers that he gets correctly. Now, for the first one, I need you to pay attention. CCC, what is random? That is the number 3. You get 3 correctly? 2, 2, 2, 1, 1, 1, 0. So if you want to talk about let X represent the number, the number of questions the student gets correctly, the random variable is going to go from 0 to 3. Does that make sense? Now, is each outcome in S equally likely? Why did I say no? Because there's only one correct answer out of 4 possible choices for each question. Even though when you come here now, you can decide to say, even though I know here, this one correct has 3. If you had only one correct, 1, 2, 3, right? Even though I know that, but for a particular question, it is only one correct answer. And the probability of of incorrect answer will be 3 out of 4. Don't forget, you got 4 options. Now, based on that, I can find the probability of S equal to 1. Okay, the probability of S equal to 1 means where we get 1 correctly done. 1 correctly done. Okay, now you're now going to go to the sample space and identify where we have 1C, which is what I identify now. Can you see that? That occur how many times? 3 times. Right now, I don't want to do binomial. I want to do normal probability calculation, and I'm still going to do binomial. You're going to see what we're going to do. Now, what is the first 1 over 4? 1 over, we said getting 1 correctly out of 3. First one will be, if it is 1 over 4, what will be second and third? 3 over 4, 3 over 4, because 3 over 4 is probability of not getting it right. Now, that will occur how many times? 3 times. And that's why we multiply the whole thing by 3. Okay, we multiply that by 3. Okay, and we have this. Now, let me tell you this. What I'm trying to say, in a sense, is that this guy is only applied to C, probability of C, where you see C, it applies to probability of C, but where you see W is 3 over 4. Incorrect. Okay, so that occurred 3 times. That was why I did that. But if I want to use binomial to do that, I'm going to use binomial formula. Now, in the binomial formula, how many questions? 3. N equal to 3. I'm going to plug in that. What is P? P is the probability of success. The probability of correctly guessing, 1 over 4, you can see. And 1 minus P will be 3 over 4. What do you see now? This now is in terms of X. Or what I'm going to do, what is probability of S equal to 1? I'm going to plug in 1 wherever I see X. then I will have it computed, which is what I have here. Okay, here I'm using binomial distribution formula. Go ahead. Exactly. But you know what? You're going to use R, and I'm going to walk you through that right now. Go ahead. Exactly. You're going to be allowed sheet in the exam. Okay, I'm going to give you information about that during revision week. Okay. Now, you can also answer a question of what is the probability of at least one? Okay, greater or equal to one. You know, greater or equal to one will be 1, 2, 3. Don't forget, everything is 0, 1, 2, 3 here. Okay, but you can also use the law of complement here, because this guy is the same as 1 minus probability of x less than 1. I needed to take a look at that. When you take a look at the law of complement, greater or equal to the opposite is less than. Let me tell you this. For discrete, there's a difference between less than and less or equal to. For discrete, there's a difference between greater than and greater than or equal to. For continuous, there is no difference. Does that make sense? Okay, less than 1, that would be 0, because a binomial is a count. Then I will do probability of s equal to 0. Okay, that's why you see that. Probability of s equal to 0, which means I'm going to go into the binomial formula here. I'm going to plug in when s equal to 0. When I plug in when s equal to 0, when I compute that, I'm going to subtract from 1, and I'm actually going to get that. But you know what? I'm going to show you how to do it in R. Let's keep moving. Now, just like every other probability distribution, binomial also have mean and standard deviation. Imagine I want to know, in the manufacturing industry, what is the average of the number of defective products we can have in our company? The average. If I want to figure out the average and it is binomial, then I'm going to multiply the number of trial by the probability of success. How do we find the standard deviation? This is the formula for the standard deviation. Okay, the two formula are in terms of the two parameters of binomial distribution. Now, based on the question, find the mean and the standard deviation of x. Now, take a look at this. How do I get that? Based on the question, you know, they say 3 questions. Each of them has 4 multiple choice, right? And one of the option is correct. What is n? N is 3. That is number of question. P is 1/4. A student that is unprepared, if a student should go into the exam out of 3 questions, you know the number that is going to guess right is 0.75. It's even less than 1. So be prepared. Don't guess. What is the standard deviation for that? That is the standard deviation for that. Okay. And you know what I want to do now? Okay. So you can be given questions. Okay. To find the mean, to find the standard deviation. If this binomial, of course, you only need N and P. But I want to quickly show you this. For normal distribution, for uniform distribution that are continuous, the probability of a random variable taking an exact value is 0. You know that? But for binomial, because binomial is discrete, that probability exists. Now, here they say, find the probability that exactly 12 of 20 randomly sample Americans or smartphones. Okay, 20 is going to be sample size, the numbers of trial. 12 is going to be X. Does that make sense? So when you plug that into the binomial formula, you see you get a result. Now, you know what I want to do now? The next 10 minutes, the last 10 minutes, I want to show you arrow codes for binomial. How do we compute binomial? If I don't want to go into those formula, that the formula may be complicated. How am I going to handle binomial? I needed to pay attention now. I'm going to start with this. Take a look at this. If x followed by norm, if they give you something like that, okay, if they give you something like that, it means the number of tries is 45. And the probability of success is 0.9. You have your n, you have your p. And the question says find probability of s equal to 40. Okay, if you want to find the probability of x equal to exactly a number using R for binomial, you're going to use d by norm. D by norm. Please pay attention. D by norm. Do you see this guy? Do you see this code? What do you see? D by norm. Can you see that? D by norm. Now, D by norm, that random variable s, they talk about 40. Your size and the p, the arrow will automatically generate that for you. Very easy. Arrow will save you from rigorous computation. Does that make sense? Exactly, D by norm. Now, the same thing here, right? D by norm, I'm going to want to find the probability of s equal to 4. I'm going to use D by norm, indicate the value, the size, the probability, and that's going to be done. But you know what? Pay attention now. Pay attention now. I want to come to number 3 right now. Take a look at this guy right now. They said find the proportion of the binomial 20, distribution that is less than or equal to 10. How do we do less or equal in binomial? It's different from the way we handle that with normal. Less or equal to, less than, they are the same in normal, but not in binomial. Now, if I want to do less or equal to, I'm going to use p by norm. You remember in normal, whether less than or less or equal to, what do we use? P norm. But in binomial, for less or equal to, we use p by norm. But for less than, we don't use p by norm. We need to do something to use p by norm. Are you ready? Now, here now, s less or equal to 10. Can you see that? P by norm. Then you write the 10. You put 20 signs under that. How do we automatically do that? Let me quickly ask this question now. What of if they want you to find the probability of s less than 10? Now, pay attention now. S less than 10. That would be s less or equal to 9. Does that make sense? When you say less than 10, what do you mean? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I'm going to do now, I'll first write this guy as p x, okay, less or equal to 9. If I want to use my p by norm right now, it's going to be p by norm. My x is going to be 9, not 10. Go ahead. You say what? You mean 9.99, for example? Oh, no. We're not going to have that value because it's not discrete. For discrete, something you can express as a whole number. 0, 1, 2, 3. I can count the numbers of defects. I can count the number of sources. Does that make sense? That's what it means. Good question. Now, take a look at this. And that's exactly what I'm doing here. Now you understand this guy now. Less than 10 is the same thing as less or equal to 9. Then I will use p by norm. 9. Some student will use p by norm. 10, they're gonna get it wrong. Now, what of this one? Take a look at this one now. You know, in the case of normal, greater is the same thing as greater or equal, right? Does that make sense? In the case of normal, if they ask you to find s greater than 10 or s greater or equal to, we do 1 minus p norm. But here, we're not going to do that. Look at what is going to happen. For greater than 56, we will first use the law of complement. What is the opposite of greater than? It's going to be less or equal to. Look at that. 1 minus p less or equal to. So the moment I see less or equal to, I'm ready for p binomial. And that is the reason why, oh my God, look at that. That will be 1 minus p by norm 56. And that is the answer. But what if in a situation where they say greater or equal to? Okay, you have a question that goes like this. X, for instance, greater or equal to 10. Okay, what you're going to do first, 1, you're gonna say this equal, this is going to be equal 1 minus, what is the opposite of that? What is the opposite? S less than 10, right? That is the opposite of that, right? If it is greater or equal to 10, then you are obviously say it's going to be less than 10. And if it is less than 10, then it will be less or equal to 9. So that you'll be able to use the binomial. It's going to be 1 minus p binomial. And that's how we do it. Oh my God, this party is over. This party is over. Okay, the party is over. Okay, that's where I'm going to stop today. Going to see you on Friday. Be sure you all stay safe. Bye for now, everyone. Okay, give me 1 second.